So today's topic is data acquisition. So what is data? Data is digital information. So if we first see that data are acquired when X-rays pass through a patient to strike a detector and are recorded. That means when an X-ray or X-ray photon passes through the other body and reaches the detector, and this is recorded, then the data is actually recorded. So when we do normal X-rays, then the X-ray is passed through the cassette or FPDU. And the X-ray is passed through the detector in CT scan. The major components that are involved in this phase of image creation are the gantry and the patient data. So now, the main factors in data collection and image creation are the gantry and the patient data. These two things are the main components. Now we are looking at a CT scan machine. So this gold part is the gantry. So excuse me, I have a phone. I put the phone. So now let's introduce the gantry. What is the gantry in details? The gantry is the ring-shaped part of the CT scanner. That means the big gold part of the CT scan machine is the gantry. It houses many of the components necessary to produce and detect X-rays. That means to make X-rays and to hold X-rays, all the components are adjusted in the gantry. And components are mounted on a rotating scan frame. That means there is a frame inside the gantry that can rotate. It can rotate all the time. This is also a rotating scan frame. And gantries vary in total size as well as in the diameter of the opening or aperture. The range of the aperture size is typically 70 to 90 centimeters. That means the radius of the gantry can be between 70 to 90 centimeters. And the CT gantry can be tilted either forward or backward. That means we can cut the gantry from the front or back. And the angle of the gantry can be tilted from 15 to 30 degrees. The gantry also includes a laser light that is used to position the patient within the scanner. That means there is a laser light to position the patient. And the control panel located on either side of the gantry opening allows the technologist to control the alignment, lights, gantry tilt and table movement. There are various switches on either side of the gantry. These buttons are called control panels. We can move the table with these buttons. We can turn on the laser light and adjust it. We can cut the gantry. These things are usually done with these buttons. In most scanners, these functions may also be controlled via the operator's console. We can control the machine by pressing the button on the operating console. A microphone is embedded in the gantry to allow communication between the patient and the technologist throughout the scan procedure. There is a microphone inside the gantry that allows the patient to hear the patient's voice when he or she speaks. There is a microphone attached to the gantry. When the patient talks, we can hear the patient's speech. And when we talk, the patient can listen to our speech. This is a gantry. This is a Siemens machine. The photo is taken from my hospital. This is a Siemens SumAtom Refinition Model AS. This is a machine with a size of 128. This machine's detector has 128 rows in the detector. We can see the inside of the gantry. This is the outside of the gantry. We will see the inside next. What is outside? There is a display. We can see how much the table is inside and how much it is outside. The table movement is shown in this display. We can see how much the gantry is tilted. There is an emergency button. If the patient gets a hand injury or gets stuck, the emergency button is pressed. If the patient gets a hand injury or gets stuck, the emergency button is pressed. There is a laser light above. There is a speaker below. There is a speaker and microphone nearby. There are buttons to control the gantry. There are two buttons here. There is a radiation light and a start scan. There is a mistake written here. The first button is the start scan. If I press this button, I can start the scan from the inside. This is the stop scan. I can stop the scan with this. It takes a lot of time to give a contrast. When there is a technician, we can give a contrast. This is the inside of the gantry. This is the outside of the gantry. There is an X-ray tube. This is the X-ray tube. Below the X-ray tube is a filament or filter. There is a high voltage generator. There are two fans and a table. There is a detector array inside the detector. The whole thing is a data acquisition system. The detector is always situated opposite the tube. The X-ray tube is located opposite the detector. The data acquisition system is the data acquisition system. The detector is inside the data acquisition system. The patient is in the mask. The patient is bathed and the X-ray is detected. The whole structure rotates over a slip ring. This is a slip ring. The slip ring technology is there. The slip ring is on the entire frame. There are many parts and detectors. But all of them are on the entire frame. This is the slip ring. This is the slip ring. The slip ring is invented. We can now do helical scan or spiral scan. Earlier, there was a cable with the X-ray tube. The cable would spin once. The tube would spin once and the cable would be pressed. The tube would go back to the previous place. The cable would move and the X-ray tube would spin again. The slip ring would make the X-ray tube spin. The tube would spin all the time. The electric supply would be used for the slip ring. Early CT scanners used recoiling system cables to rotate the gantry frame. The previous systems had recoiling cables. These designs limited the step and should move method, and considerably limited the gantry rotation times. Earlier, we could only do the step and should move method. Because of this, the gantry rotation time was limited. We could only do the gantry rotation once. Current systems use electromechanical devices called slip rings. This is an electromechanical device. This is a slip ring. All parts, X-ray tube, detector, generator, etc. are installed on it. There is a cooling system inside to keep it cool. The slip rings use a brush-like apparatus to provide continuous electrical power and electronic communication at close to the rotating surface. This is a rotating surface. Because of this, everything can rotate. There is no problem in rotating continuously. They permit the gantry frame to rotate continuously, eliminating the need to straighten and push up system cables. The previous system had a method of keeping the cable in place. But in this system, no cable is required. The gantry can rotate continuously. The X-ray tube, detector, and other parts can rotate continuously over the slip ring. This is a high-voltage generator. This is inside the gantry. This high voltage is required for X-ray production. The power capacity of the generator is listed in kilowatts. The power is given in kilowatts. The power capacity of the generator determines the range of exposure techniques, such as kilovoltage and milliampere available on a particular system. This high-voltage generator provides the required amount of kilovoltage or milliampere supply to the X-ray tube. CT generators produce high kilovoltage, generally 120 to 140 kilovoltage, to increase the intensity of the beam, which will increase the penetrating ability of the X-ray beam and thereby reduce pressure dose. Due to this high voltage, the dose of radiation in the gantry decreases. This is because the high penetrating X-ray is very strong and the beam goes inwards. In addition, a higher kb setting will help to reduce the heat load on the X-ray tube by allowing a lower MA setting. Due to this high voltage, the heat of the tube decreases, because we do not need to supply more current. Reducing the heat load on the X-ray tube will extend the life of the tube. The colder the tube, the longer the tube will be. As much we can keep the tube cool, the tube life will be longer. There is another cooling system, which is a cooling system for cooling the X-ray tube. The cooling mechanisms are included in the GNP. If we consider the cooling system, this is an X-ray tube. If this is an oil cooling system, then there is oil around the X-ray tube. To cool the oil, the heat is absorbed from the X-ray tube. After the heat is absorbed, the oil circulates in the system. If the heat is absorbed, the heat is absorbed by the fan. There is a liquid-to-air heat exchanger, which is used to suck the air, and the fan is used to suck the air. The fan is used to cool the oil. After cooling, the oil is used to circulate through another pump. The cooling system is used to work with the circulation of the oil. They can take different forms such as blowers, filters, or devices that perform oil-to-air heat exchange. There are different kinds of cooling systems like blowers, filters, and oil-to-air heat exchange. This is an example of oil-to-air heat exchange. Cooling mechanisms are important because many imaging components can be affected by temperature fluctuation. If the temperature is not right, then the machine will not work properly. This is why the cooling system is useful. Now we will see the X-ray tube by X-ray source. This is an X-ray tube. The X-ray tube produces the X-ray photons that create the CT image. When the X-ray photons come out of the tube, the X-ray photons enter the body of the patient. Then the detector collects data and sends it to the computer. The computer processes the CT image. Their design is a modification of a standard rotating anode tube. There is a rotating anode tube in the X-ray that can rotate at all times. The anode can rotate inside the tube. Among tungsten, an atomic number of 74 is often used for the anode target. Because of the high atomic number, tungsten has the highest boiling temperature. This metal is used for anode target and produces higher intensity X-ray beam. So, the more atomic number of target material, the more X-ray production. But the boiling temperature of the metal is also high. CT tubes often contain more than one size of focal spot. 0.5 and 1 mm are common sizes. There are 2 or 3 focal spots. The size of the focal spot is 0.5 mm to 1 mm. And just as a standard X-ray tube, because of reduced in number of small focal spots in CT tubes, produced sharper image, better spatial resolution. But because they concentrate heat onto a smaller portion of the anode, they cannot tolerate as much heat. So, the reason for this is that the X-ray is very sharp. And the image resolution is very good. But because of this, the heat is produced again into the anode. And the anode cannot take much heat, because it uses a cooling system again. Another component is filtration. So, filtration is a kind of filter. We know that filters are used to filter the glass. So, what filters are used in X-ray? Compensating filters are used to shape the X-ray beam. So, to keep the shape of the X-ray. The X-ray is called the low X-ray, the soft X-ray. The soft X-ray filters the filtration. And the hard X-ray passes the filtration. And the soft X-ray increases the radiation dose. And creates the image and image artifacts. So, the long wavelength or soft X-ray filters the X-ray. These long wavelength X-rays are readily absorbed by the patient. Therefore, they do not contribute to the CT image, but do contribute the radiation dose to the patient. So, if we do not add these soft X-rays to the filter, then the patient's radiation dose will be reduced. In addition, creating a more uniform beam intensity improves the CT image by reducing artifacts that result from beam hardening. Because of the filter, we get a uniform beam. So, there is an extra intensity in all places. This kind of beam is found because the artifact decreases